Hello everyone. Today I am going to start the Cambridge International AS level core paper. So this is paper 22. This is paper 22 and the variant is like 9702 variant number 22. So this is a theoretical paper. So we have to answer each and every question. This is not a MCQ type question. This paper is all about solving your question and apply your skills and techniques and formulas and the concept you have learned in your syllabus. In the start, you have some data for calculation like the constant values for each thing and some formula to remember. Okay. And you have to make some formulas by yourself. So in the first question, they are asking about that in the following list, underline all the units that are SI base units. We know that there are a total of 7 SI base quantities and their units. So, you know, like mass, time, temperature, current, intensity of light, like mass in kilogram. So, kilogram is here. Time is in second. So, second is not here. Current is in ampere. So, this one. And temperature. But temperature is always in Kelvin, not Celsius, and Newton is a force and which is a derived quantity. So it is not a base unit. So it means that only two quantities are from the list are SI base unit like ampere and kilogram. Okay, I have written like 1, 2, 3, 4, 5, and the other things are like amount of substance, mole. Can you tell me the last one? So the last one is length and which is in meter. So 1, 2, 3, 4, 5, 6, and 7. Okay. So in the next question, they are talking about that in figure 1.1, this show a horizontal beam clamped at one end. It is fixed at this end with a block attached to the other end, and the block is attached to the other end. The block is made to oscillate vertically. The block is now, if we give it a little push from here, it will move up and down, direction of oscillation. And the Young modulus E of the material of the beam is given by E is equal to K M divided by T square, where M is the mass of the block, T is the period of oscillation, and K is the constant. Now you got all the quantities. Okay. A student determines the values and percentage uncertainties of K, M, and T. K mean constant, M mass, and T time. So the table 1.1 show the percentage uncertainty of each value. Like K has a percentage uncertainty of 2.1, mass has 0.6, and time period is 1.5. Okay, the student uses the values of K, M, and T to calculate the value of E. E is the Young modulus, and which has a value of 8.25 into 10 to the power 9. Now they are asking about the calculating the percentage uncertainty in the value of E. We have to find the percentage uncertainty. We know that the rule of uncertainty, we have read that if the formula contain multiplication or division of values, we add their percentage uncertainties. Okay, so in the formula we have Km and T. Km is multiplying and T is like dividing, okay, in that denominator. So we have to add all these percentage uncertainties together. But there is one thing you have to be very careful, like the power. We have a power of time period and the power is t square. So what we do? We just multiply 2 with the percentage uncertainty of time. Okay. So percentage uncertainty in E will become 2.1 percentage plus mass 0.6 percentage plus the time period is 1.5 but the power is 2. So we just multiply 2 into 1.5 percentage. So if we calculate it, so what we will get? 2.1 plus zero point 0.6 plus 2 into 1.5. So the answer will be 5.7 percentage. 5.7 percentage. So this is the percentage uncertainty. We have used two rules. The first one is if we are going to calculate the percentage uncertainty, we have to add all the percentage uncertainty given in the question. And if there is a power, so the thing is we have a power of time period. So we have to multiply the time value like 1.5. 1.5 is the value of t, but here is the power is 2, so we have to multiply it by 2. Okay, so it will become 3%. So you can do directly like 3 plus 0.6 plus 2.1, so you will get the answer of 5.7. I hope you got this. Now the second part tell us that use your answer in B1 to determine the value of elastic modulus with its absolute uncertainty to an appropriate number of significant figure. Now we have to find the absolute uncertainty. For finding the absolute uncertainty, we know that we have to multiply this value with the percentage uncertainty. Okay, like how? Like we have the value of 8.245. 8.245 multiplied by 10 to power 9 multiplied by. What is the percentage uncertainty we get for Young modulus? 5.7. So we'll write 5.7. Instead of percentage, we will divide this by 100. So this is the absolute uncertainty of Young modulus. So if we calculate this, what we will get? Wait, I will solve it for you. We get the answer of 46996 and 3 zeros. So can we make it like how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can create it like 0.46 into 10 to power 9, or we can approximate is equal to 0.5. Okay, and we have the answer in, we have the power of 10 to power 9 in outside, so we have to just write here 0.5 or 0.46, and here you can write your answer like 8.245. Okay, now the total question is for 5 marks, so you have to do proper calculation in order to get full marks. Okay, so we are moving to the next question. Okay, in the next question, they are talking about that a sphere is attached by a metal wire to the horizontal surface at the bottom of the river as shown in figure. A sphere is attached with a string and attached with the horizontal surface below the water. Okay. The sphere is fully submerged. It is totally under the water and in equilibrium with the wire at an angle of 60 8 degrees to the horizontal. The angle is with 68 degree, this angle, this. The weight of the sphere is 32 Newton. The overall weight of this is 32 Newton, like this one. And the upthrust acting on the sphere is 280 Newton. And the liquid is pushing this sphere upward with the force of 280 Newton. And we call this upthrust, okay? Now, the density of the water is, and we have given the density of water is 1 into 10 to power 3 kilogram per meter cube. Now we have three conditions, like we have the angle with which the sphere is moving along the direction of water, not moving, but due to some water force, it is creating an angle. It is not just a straight one, it is at some angle 68 degree. We have its weight, we have its upthrust and the density. Assume that the force on the sphere due to the water flow is in the horizontal direction. We have to assume that the force on the sphere due to the water flow is in the horizontal direction. We have to assume that the force on the water acting is in the horizontal direction. By considering the component of the force in vertical direction, now you have to be very careful about the question, what they're asking. We have to see the force along the vertical direction to determine the tension in the wire. We know that in horizontal component, we use cos of theta, and in vertical component we use sine of theta. So we have to consider the forces, okay? So we know that upthrust is equal to tension plus weight, because weight is downward and tension along the string is in this direction. So tension and weight both are acting downward and the resultant upthrust is acting upward. So upthrust is 280 Newton. We don't know the tension, but we know that the tension is along the angle and we have to solve the vertical direction. So tension is a vertical component to sine of 68 plus weight is 32 Newton. You got my point? So here the tension will become 280 minus 32 divided by sine of 68. When we solve this, we will get the answer of 267 or approximately 270 Newton. You got my point? Okay. For the sphere, calculate the volume. Now we have to find the volume. We know that we have to find the volume of this sphere. So in order to find the volume, we know that we have two formulas. Upthrust is equal to rho GV. We have upthrust, we have density, and we know the value of gravity. So we can find the volume V easily. And also we can find but the question is for sphere. So we cannot use directly the formula of density is equal to mass over volume because we don't know the density of sphere. We just know the density of the liquid, the upthrust acting on it, and the gravity. So we will use this formula, not this one. So the volume will become upthrust divided by rho and G. So upthrust divided by density into gravity. So upthrust is 280, density is 1 into 10 to power 3, and gravity is 9.81. So we will get the volume around 0.029. Okay. So now we have the volume of sphere. Now by using this formula here, so density is equal to mass. We don't know the mass, but we know that the weight is equal to 32 Newton. So weight is equal to mg. So in order to find the mass, what we will do? Weight divided by gravity. So we have to use the weight divided by gravity. So 32 divided by 9.81. This is become the mass and divided by volume. And we got the volume from here. 0.029. So when we solve this, we will get an answer of 110. kilogram per meter cube. I hope you got this question and the sense of doing this question. Okay, now they say that in the C part, the center of gravity, sorry, the center of the sphere is initially at a height of 6.2 meter. Initial height is 6.2 meter above the surface of water. The speed of water then increases, causing the sphere to move at a different position. This movement of the sphere causes the gravitational potential energy to decrease by 77 joule. There is a decrease in gravitational potential energy. So it means that when the water is flowing at a high speed, so the new position is like this, which cause the change in gravitational potential energy, and we have the less potential energy, which is 77 joule, like it is decreased by 77 joule. So we have to find the final height of the center of the sphere above the horizontal surface. Now we have to find the new height, the final height after the loss of potential energy. We know that change in potential energy is equal to mgh. So mg, we know that W is equal to mg, so we will just use the weight here. So change in potential energy is minus 77 joule because it is decreased, so we will use negative sign. Is equal to, this is weight, we have is 32 Newton, and h. So h will become minus 77 divided by 32. Let me solve this for you and tell you that what I got for this. 77 divided by 32 will give me 2.4. So the answer is minus 2.4 meter. So the final height is initial height is 6.2 and the new height is 2.4. So just subtract them. So what we will get? We will get 3.8 meter. So we can just write here 3.8 meter. Now, the question is, the extension of the wire increases. The extension of the wire increases when the sphere changes position as described in C. The wire obeys the Hooke's law, and the wire is also obeying Hooke's law. State the simple equation that gives the relationship between the tension T in the wire and its extension X. We have to use the tension, extension X. Identify any other symbol that you use. We know that Hooke's law is just like F is equal to Kx. F is the force, K is the spring constant, X is the extension. But in our case, we have tension, like force is equal to tension, K is the wire constant, and X is the extension. So what the formula will become? T is equal to Kx. So in the next part, they are talking about before the sphere changed position, the initial elastic potential energy of the wire was 0.65 joule. The initial elastic potential energy of the wire was 0.65 joule. The change in the position of the sphere causes the extension of the wire to be doubled. Now the extension is doubled. Calculate the final elastic potential energy of the wire after the sphere has changed the position. Now we have to find the new elastic potential energy when the extension is become doubled. Okay, so we have elastic potential energy equals to 0.65 joule, and the extension is doubled. Okay, now we have to find the new elastic potential energy. Okay, first we will find we know that EPE is equal to half of Fx. First we will find that if we have 0.65 joule of elastic potential energy, then how much extension we have. Okay, so now you are figuring out that what is the force, like what is the total force. So we have calculated the force around 270. like this one, tension. The force here is tension. So you can just use half of Tx. I can make it Tx, okay? So EPE is 0.65 into 2 divided by 270 is equal to x. So the extension will become 4.8 into 10 to power minus 3 meter. Now we got the x value, the extension. This is the first part. Now I am going to do the second part. We know that f is equal to kx, so I can find the k value as well. So it will become T is equal to kx, and I have to find the value of k in order to find the final elastic potential energy when it is the extension is doubled. So I will just put it like tension over x. So we know that tension is 270 divided by, we know the extension 4.8 into 10 to power minus 3. So the k value will become 5.6 into 10 to power 4. Okay. Now, when the extension is doubled, now I have to find the new elastic potential energy. Now I am going to use the new formula EPE final. F is for final. This is I initial. Okay. So the for final elastic potential energy, I am going to use half of kx square. Now you got my point. Half, we know the k value, which is 5.6. So I am using 5.6 into 10 to power 4. And the extension is doubled. Please keep that thing in mind, that the extension of the wire is doubled. So now we have to use double extension. So 2 into 4.8 into 10 to power minus 3 and the square. So when you solve this, you will get an answer of 2.58, approximately equal to 2.6 joule. I hope you got this point, and we have solved almost 2 questions, and the overall number for this question are 11, and for the previous one they are 5. I hope you like this question solving and you understand the concept better, in a better way. Hopefully see you in the next class. Bye bye.